All right. Hi. This is the third and final workshop for the series for Gay Gaming Pros. So stoked to be here, stoked to be doing it. We'll do some basic stuff, just kick us off to get it going, and then we'll go. So this is called optimization tips and tricks. And I wish I could say that we were going to throw an audible and just talk about like pizza crafting, but we're not. We're going to talk about optimization because it's almost as important as pizza. It's like 2% less. So as we dive in, this is a disclaimer specifically for me. It's actually not a disclaimer for Utsav because he is in fact an optimization expert. But I write code and teach, and I don't think I'm an optimization expert, but I give you a lot of tips and tricks and ideas. And you're not allowed to disparage pizza in this chat. So just so you all know, it's just a rule, general rule of thumb. If you're in the Makers Discord, enter the giveaway by clicking the React button. So check that out as well. Real quick introductions if you haven't been to it before. Hi, I'm Thomas Winkley. I'm a technical marketing advocate at Unity Technologies on the academic nonprofit team. And I'm joined by a super dope developer, that guy.
What's up? My name is Utsav. I'm a product manager since May of this year. But before that, I actually used to optimize games for some of our biggest studios. I can't say their names because that would be breaching NDA. But I've been doing this for a long time, and I'm happy to be here and just talk about optimization.
Yeah. So yeah, when this topic came up, I was super excited to partner with Utsav because I'm like, I know a guy that knows everything about optimization you could ever think of. We actually got our last team offsite. We got in a very not heated, but a very passionate discussion about all the chaos that can be created if optimization is not good. So this is going to be a fun discussion. So with that, we're just going to dive in. And I'm just going to start with my general thought of it's a lot easier to make small adjustments at the end of a game than it is to overhaul your entire game. And so what we mean when we say that is optimization starts at planning. And it starts at your prototype, right? There's no reason that you can't write good prototype code in case that code makes it into production. Couple thoughts there. If you do a lot of debug statements to test, things like that, right? You can already set up like debug flows that maybe don't make those work unless you really, really need them. But yeah, Utsav, what do you think about this? What are your thoughts on planning for optimization and starting optimally off the jump?
Yeah, no, I think that's a great point, right? Because I think a lot of us have tendencies to kind of brute force something when we start building things, especially when you're in that initial rush of you have an idea, you want to put pen to paper, and you just want to see something happen, right? But like you said, I think I can't stress enough how important something like a TDD is, even if you're doing a prototype, because that allows you to think about the larger application rather than the single thing that you're looking to build right now, right? And I think in our previous workshop, if anybody attended that, we talk about how prototypes are something that should be thrown away, right? But if you do write good prototyping code, you can actually, move that code as a modular piece of code, like a function, into your actual code and reuse it in different ways. Right. So yeah, I think that's a great way to start this off.
Yeah, definitely. You'll see that theme through all of our workshops. We talked about planning, game design docs, technical design docs, writing down stuff, referencing back to those when you go back. It's probably the most important and most I don't think it's talked about as much as it should for how important it is to your game dev cycle because it impacts every step that you're ever going to take. So with that, now we've talked about this take, let's talk about optimizing for graphics, which I think is a very complex thing to talk about. Yeah, it's very complex. So let's just dive into it. Words are hard today. I apologize to all of you. So as we dive in, there's a couple of terms we're going to talk about. And so yeah, this is dynamic batching. Dynamic batching is basically the power. It takes all their vertices and on the CPU and it groups similar vertices together and it's going to draw them all in one go, right? So that it's actually drawing like positioned things at the same time, right? Which saves it a ton of time. Static batching is going to combine not moving stuff, right? Static means fixed, unchanging, the same. And so you're going to want to employ this when objects are not moving. It's actually going to combine them into a giant mesh and then render them all together in a faster way. But there's some rules for this, right? When you want to enable this on your setup. So they have to share a material in order to be batched statically or dynamically. This is a really good note here is if you're ever accessing a material, right, you have renderer.material. So that actually creates a copy of the material when you access renderer.material. But renderer.shared material modifies the shared material in the entire environment. And this is something that I mess up all the time, like once a week. Because I'm like, oh, I'm just going to change the color of this material really quick. I'm just like, all right, render.material equals this. And then I hit the thing and the material doesn't change, or something, part of it doesn't work right. And I'm like, that's very strange, right? And then I go, oh, right, because it's the shared material, so it's shedding the exact same one that we're all sharing. And there's a ton of other rules you can check out here. Docs.3D. There's a link here, and we can drop this in the chat for you all. Copy link address, yeah. But it's also worth noting that if you're doing batching in the scriptable render pipelines, that is actually shader based rather than material based. So that's everything I know about batching set on a slide. Utsav, how do you feel about batching?
Yeah, no, that was a great overview, and I think I'll just add to some of the things that you've said, and for example, going back to dynamic batching is for very special use cases. Most of them would revolve around rendering mesh particles, because dynamic batching requires you to do real-time mesh transformation, which can be really, really expensive. So what we do is we put a cap on the number of vertices you have, and if you weren't aware, a vertex is just a single data point which holds all the information about a mesh at that data point, right? And that data point is stored locally as a local coordinate, and then you go to world coordinate, and you go to screen coordinate, and so on and so forth as you translate the data from a scene onto your screen, right? So in order to do that transformation in real time, we need to cap the amount of vertices so that the computer doesn't just, that's all it does, right? If you're trying to do thousands of words at the same time, which is why there's such a big constraint to dynamic batching, right? When it comes to static batching, this is actually not a real-time thing. So the combination of meshes actually happens pre-runtime. So once you mark the meshes as static during build time, Unity will actually combine all the static meshes in your scene in order to render it as one big combined mesh. Now, you could be, this could affect your performance poorly if there's a lot, if there are very big meshes and there's no occlusion happening because the whole scene is a single mesh, right? So that is a problem that we ran into on Oddworld Soulstorm. So, we were optimizing Oddworld Soulstorm, and you would see these frame rate drops when you'd have a large vista, or even if you were looking at the large vista, if you could just have a little clip of the little mesh that's part of the large vista, our frame rate would slow down. And we realized that was because that little part of the mesh was actually rendering the entire vista, right? So some things to keep in mind.
Yeah, and that's really important to think about too, right? For those who may not know, so like as I've talked about occlusion, right? And occlusion basically means like something's blocking me, don't render me. Like it's very important to think about those types of things, because even though your eye can't see it and maybe the camera can't see it, that doesn't mean that the GPU is not thinking about it, right? And so you have to set up systems in order to translate that. Now, conversely, in the world of optimization, and I'd love to hear your take on this, Utsav, because I've heard both ways for some other work I've done, but I've actually heard that depending on how intense your culling system is, that can actually be a performance problem in and of itself, because it's processing so much information to basically be like, hey, like I need to know everything that I should show and don't show. And that actually is just as taxing as just not having the system.
Yes, absolutely. So there's different kinds of occlusions you can do, and depending on what your bottleneck is. So I think this is where profiling comes in really handy, right? Because when you're drawing things, generally that operation is happening on the GPU, but culling is the operation of coagulating all the draw data before you send it to the GPU. So now let's assume you're trying to optimize a game and you're running at 20 frames per second. The first thing to do is to understand, is the CPU the bottleneck or is the GPU the bottleneck, right? So let's say in this case, your CPU is the bottleneck and your GPU has another 10 milliseconds to spare and could use up that time. In that case, you can see your culling taking up extra 10 milliseconds on the CPU. You're like, okay, I'm just going to scrap the culling and let the GPU render everything, and I'm still going to come in under 33 or 16 ms, depending on your target frame rate being 30 frames per second or 60 frames per second. And I apologize if I'm going very deep and using acronyms that people may not be familiar with. So feel free to like post your questions if you don't know something or
Yeah.
don't understand something in the chat. Um, yeah, so yeah, definitely. I think you have to really kind of understand what's causing the bottleneck in order for you to approach it in a meaningful way and solve it at the spot.
Yep.
And then I'll also, talking about SRP batching, I think SRP batching. So going back to static batching, that works with built-in render pipeline, which we also refer to as burp. And then universal render pipeline, or URP, and HDRP both are built on scriptable render pipeline. So technically, URP is just a pre-templatized scriptable render pipeline. If you wanted, you could just download the scriptable render pipeline and build your own render pipeline. The caveat there obviously is that you have to maintain your own pipeline, right? Which could be very, very resource intensive. But SRP batching that works, out of the block with out of the package with URP and HDRP allows for shader-based batching. And what that means is, if you have a few objects in your scene and they all have different materials, but all of those materials use a single Uber shader, as long as that shader has properties set in a constant material buffer. And I know that might be a little too advanced if you don't know, but there's a lot of documentation on it. So if you just look for unity per material constant buffer on Google, you can find some information. If you write your shader that way, it will allow you to batch objects with multiple different materials, but with that share the same shader into a single draw call. Now, there's another caveat to that. So depending on how you're looking or profiling the data and getting the data about draw calls, if you look through Unity's frame debugger, you'll see that it says SRP batch, but then in bracket, it says the number of draw calls. That's because they're not technically a single batch, they're instanced draw calls. And what I mean by that is, if you were to open the same screenshot, the render screenshot, instead of in the frame debugger in render doc, you would see that a single SRP batch might have 12 different draw calls on them, but they will all be instanced. And what that means is that Unity has prepared a buffer in which it stores all the material data, and it's never going to delete any material data from it, because all the properties that a material can have, that buffer does have. All it does is updates that property for each object. So, for example, if one object uses an albedo, but the other one does not, it just removes the albedo from that material buffer and renders the next object. And that is a lot quicker operation than having to reload an entire buffer with new material properties. Anyway, I'm sorry if that was a lot of technical jargon.
No, no, I appreciate that, because I think it shows that, like, there's, with optimization, you can go from very basic stuff to make it better, all the way to exactly what you described, right? Like writing your own shader to make sure it takes care of, or I'm going to say this wrong, but mass uses the Uber shader and is allowed to then be batched and drawn that way, right?
Right.
For a few terms were mentioned there that I want to call out. So we talked about milliseconds. So for those that may be newer to this and they're like, oh, I don't know what that means. So when we talk about milliseconds, that's the time spent on the operation at a cost for like rendering or processing, right? So when we say, oh, well, that's 13 milliseconds on the GPU, that means it is taking the GPU 13 milliseconds to render that frame, right? And in a fixed frame rate game, 30 frames per second, 60 frames per second, even though technically, I guess time is a construct, but like you have a fixed amount of time between it, right? Like 60 frames per second, you have 0.02 seconds, right?
Yeah, 60 frames per second is about 16.66 milliseconds.
Okay, so that's how much time you have to render a frame before you go to the next one, right? And so we talk about optimization like this because if something like this happens, like say you have 16 seconds to render and it's taking 33 seconds, that means that half of your stuff isn't happening in time, right? And so then that stuff is delayed, and so correct me if I'm wrong, but it's delayed to the next frame to catch up, right?
Correct.
And so now suddenly you've got a 33-second render, and you've got to do that 33 seconds in your 16 seconds plus another 16 seconds that you missed. and the problem piles up. So that's why we talk about things that way. Another term you're going to hear a lot in optimization or any kind of computing is we say expensive. We're not talking about money. I mean, we might be talking about the RTX 4090, and then we can talk about expensive, but we're talking about actually the cost on the processor and the cost on the GPU. Like, what does that take the resources to do? Like, what's the actual resource cost of that product? So when you hear expensive, I think those are the two terms I caught on to there. But yeah, a lot of cool stuff in bashing. Let's talk about UI, because I honestly believe that at a intermediate to beginner level, this is a big pitfall. And there's a lot of really fun things here we can talk about. So Unity renders UI as a mesh, right? So we take that UI, we make it a mesh, we render it. And every time you update a UI, it redraws it. So if you have a UI set up, let's say just one canvas, but that canvas has 60 pieces of text and 70 panels and 5 images, but only 5 pieces of text are changing. Every time one of those 5 pieces of text change, that entire canvas is redrawn and updated. So if you really need to save draw time on that, right, you might not need to, but if you need to, you can actually organize your UI with static and dynamic components. So all the stuff that doesn't change can live on its own in its own group. And then the stuff that does change would live on its own separately. And that way you're actually reducing the amount of stuff that's redrawn, because you're only redrawing the dynamic stuff, which is the stuff that's changing. And all the static stuff is hanging out, doing its thing, being ignored, because the processor or the GPU can just look at it and go, you're not changing. Great. I'm moving on, right? It's a quick check. It moves on. Looks in the door. It's really quiet in there. My dog's eating the couch. Nope, they're sleeping. Shut the door, move on. So it lets your processor move on and move quicker. So.
Yeah, no, and I think that's definitely one of the biggest things I've seen with UI, and I've run into games where out of the 33 milliseconds they want to run for 30 frames per second, about 15 is being used up by UI. That only leaves you 17 milliseconds to do anything else, and that includes things like physics, drawing the actual game, doing any game logic, preparing for the next, keeping inventory, right? All of these systems then have that much amount of time left. So I will add a couple of things for UI optimization. So obviously, like you mentioned, static versus dynamic components, very important to separate them out. There's a few ways you could keep them together. One would be using tweens. So tweens don't register with Unity's object, changes and transformation the same way animations are dynamic. Other dynamic components do, like transform changes. So including tweens for very basic animations would allow you to keep a single. Yep, there we go. Esther knows what's up. That would help you to keep your UI simple, straightforward, and together. But I will say that it's probably going to become very complicated if you have lots of UI animations. At that point, separate your canvases out. Another way of doing it is having sub canvases. That way you can, instead of having 2 main canvases or completely different hierarchies, you can have sub canvases and separate out elements that way. And then I think another thing.
So
Yeah.
So when you say sub, so I could still have one parented UI manager and have all the different. So Unity is actually grouping by drawing by canvas, not by top parental object. The canvas is defining the redraw.
Correct, because canvas is what's translated into a mesh. The canvas is essentially what the final mesh, the quad mesh, will look like, and get drawn on. So yeah, and then another thing I would probably add with UI, probably a smaller thing is, deeper hierarchies do add to canvas drawing, right? So for example, if your hierarchy is just 1 or 2 levels down, even if you have to redraw the canvas multiple times, it may not be very expensive. But when you have deeper hierarchies, it takes that much longer for code to parse through the canvas hierarchy to redraw it over and over again. And then another thing is, once your canvas is set on your screen size, because you are dealing with multiple screen sizes, right? So you're gonna need to do column and row adjustments for each screen size. But once that adjustment is done, you should save that layout and never have to redraw the layout on the same device again. Because redrawing the layout every time something changes adds another element to what operationally your CPU has to do. And a lot of these operations happen on the CPU and not the GPU. The reason for that is we don't actually, like, the GPU is not the one that's translating the objects into a single mesh before rendering it. CPU does the work, and all it does is it tells the GPU, hey, here's the mesh I want to draw, here's where I want to draw it on the screen, and these are the textures and resources alongside it. So it's the best to make canvas, do not destroy on load, and do 2 canvases, one for yes. And then in terms of do not destroy on load, I think that kind of depends on what your game requirements are, right? If you have a persistent HUD, yeah, you probably want to do a do not destroy on load. But if you have a specific menu screen that comes and goes as you want, I still wouldn't destroy it, but you can find ways of making transparency 0. So for example, using a canvas group would work better than deleting the canvas and remaking the canvas. Does that answer your question? I hope so.
And to add to that as well, the transparency 0 idea is actually really good, because something I still actually try to do here and there, and I have to code around it, is I deactivate the object and reactivate the object. Problem with that being, if you have scripts that are going to reference or try to do things to that object, if it's deactivated, it's not findable. Like, those scripts will not fire as you need them to, right? So setting it to transparency 0 is a really, really great workaround on that, so that you can just access it as you want and not have to think about that. Otherwise, you have to basically have it update on awake or update on activate and figure things out that way. And I don't know if that's necessarily bad or good. It's just a thing you have to think about. So just a caveat there for all y'all. So I feel weird putting this one here, because I feel like it's a 1990s conversation. Like, I can't. So, and I'm explaining this to you all why. We're gonna go to Old Man Tom's story corner real quick. So, like, I think about, like, when, if y'all remember the Voodoo graphics card that came out in like the 90s ish, and it was like the blue Voodoo. No, that's an amp. It was something Voodoo, but they had this like picture of 3D, and it was like best polygon count to date or something. Like, that was a huge marketing factor back then. But it actually is a really important part of what we do, right? So we, triangle counter, poly count, more triangles, more rendering, lower performance, right? The more stuff you got to draw, the more faces there are, the more stuff's thinking about it, harder it is, right? Just kind of like you're eating a bag of potato chips, you're trying to sort the chips. If it's a small bag, you're gonna get done a lot faster than if it's a big bag. Man, I'm kind of hungry. I wonder if that's why I'm making food references today. So this is, of course, really subjective, right? Because you may want your game to run with tons of triangles. You might have different production budgets, but yeah, it's what do you think about triangles? How do you feel about that shape generally?
Yeah, no, I like the shape personally, but I think one game I can refer to that I think just last year I was working on this is Outer Wilds. So I worked very extensively on Outer Wilds trying to optimize it for Switch. Our biggest problem was the amount of triangles. It was like there were scenes, and the way Outer Wilds is set up is that technically everything is a single scene, but I can't go into more detail. But regardless, there were times when there were millions of triangles on the screen trying to render, all while game logic is running and physics is happening, and other things are happening, right? So I think reducing your triangle count, I think, can be tricky in the sense of, like, you think you want more fidelity, and you're like, how do I add detail to my model? I'm going to add bevels. I'm going to add all of these things. But there's a few ways to kind of get around some of those problems. One is normal maps. Normal maps are your friends. Normal maps take detail that you want your models to have. It's very easy to do. In fact, one of my initial works in games included me writing my own renderer, and how I would test my normal maps is literally I'd create a normal map where it would seem like there's a crater and a triangle coming out of a side of a cube. I knew it was a straight cube because I rendered the whole thing, and then I'd shine a light on it from different angles, and then see where I get less light versus more light, and all of that kind of depends on what your normals are pointing at. Again, I might be going a little too much in depth here, but the point I'm trying to make is, like, find ways to reduce your triangle count, but keeping your visual fidelity, right? So normal maps would be one. The second option is culling. I think going back to culling, you might have 5 million triangles in your scene, but there's a lot of walls, right? And the player is going from one room to another room to another room, right? Just render one room at a time. You still have all the polygons and triangles that you need, but you're not rendering them all at the same time. Your computer's not going crazy, pulling its hair out if it was a living thing, right? So I think, and then I think third, which is the most basic way, figure out how to model your assets while keeping your triangle count low, right? So like, for example, if something on your screen is going to be small, use LODs, right? So let's say, for example, in Outer Wilds, if I'm flying onto a planet, I don't need to have every detail on the planet be rendered out while I'm, a mile away from the planet, right? As I get closer, see how far I am from the planet, and then change the mesh that is being used to render whatever you're looking at with a more detailed mesh. And as I get closer and you can see more detail, change it again, right? So you could have 4 different levels of LODs. And when I say level LOD, that just means level of detail. So level of detail could work in different ways. It could be meshes, it could be textures, right? So for example, have a character have their entire texture set on a 512 by 512 atlas when you're a mile away, but when you're right in front of them, maybe their entire texture set is 4K instead, right? So that allows you to kind of control a lot more of what your computer is working through in terms of rendering your triangle count and having the number of assets on screen.
Yeah, I'm glad you brought that up because that was actually the first thing that hit my head, right? And that's how our eyes work. Like, so no one's gonna notice. Big thing about game dev, I like to think about work smart, not hard, right? Game dev tricks. I don't know if you've ever seen like those things where they break the cameras in games to get like really cool screenshots, and sometimes they go behind a building and the back half of the building is missing. It's because they never render it, so why build it, right? Like, why build what you're never going to use? So same idea with LODs, right? If you're only going to see an object a mile away, you don't need it to be in 4K. But if that object is going to be right in front of your face all the time, maybe that one should be 4K. I heard a fun anecdotal story from a VFX artist while just talking shop about how they were working on a game, and the texture for the fire in the scene had to be like super light, like 256 by 256. But the texture on the character's hand holding a pistol that you never saw the inside of the hand was 4K because you saw the rest of the hand, so it had to be super high. Like, so totally a good way to like balance that budget. And that's really good advice from our man itself. All right, cha-cha. When it's possible, bake your lighting. Put some sugar on it, maybe some frosting, slide it in the oven, let it cook, pull it out. Delicious, right? For those who don't know, baking just means pre-process. So real-time lighting and baked lighting are different in the fact of, like, if I walked past a baked light source and I'm a dynamic object, I'm not going to cast a shadow because I'm not interacting with that light source, right? So in light sources that you need to cast shadows, you need to have that color computed at real time, do it. Put real-time lights out. But if you don't need to, you can bake lighting and cookies and brownies and cakes, like all that stuff. But bake it because then it's all pre-processed. And just like I believe Utsav was talking earlier about referencing like a lookup table, essentially, right? Looking and in that buffer and going, oh, I just need this, I just need this, I just need this. It's the same thing here. Is now there's a big lookup table, and it can just go, all right, this pixel's this color, this pixel's this color, this pixel's this color, and it's not calculating that in real time, and it's saving you movement, saving you work.
Yeah, no, absolutely. And I think light baking is such a tricky thing, right? Because a lot of times you're like, hey, game dev is about iteration, but it takes me an hour to bake my lights for the entire scene. Well, true, but there are ways you can manage that. For example, in Unity, when you're using the light mapper, you can use there's a property called texel density, and what that means is how detailed will your light data be on a particular mesh that's part of the scene that is being baked into, right? So you could increase the texel density that your entire scene is just 8 texels, right? And that allows you to kind of see what a preliminary bake result would be, and it would take 100 times less time than it would for you to bake at full detail. So that's one thing. And the second thing is there's how Thomas mentioned, if you're a real-time object, you won't be affected by the light that's there. Well, there's a thing called mixed lighting. And what that means is in your scene, as you can set some objects to be static, but you can set your light to be mixed. So that way, all of your static objects have lighting baked onto them, but your real-time shadows, as dynamic objects move in the scene, that light remains there, but only affects the shadows from the real-time objects. So what that means is that Unity doesn't need to compute what the color of a static object would be, only recalculate the shadow map each time something moves. And then there are ways to kind of optimize the shadow map, right? You can have different canvases of shadow maps. So like, for example, depending on how far an object is from your light, they might render into a smaller 256 by 256 shadows. That way your shadows are not very crisp. But if the light source is right next to the object and so is the camera, then maybe you render into a light map which is 4K so that you get crisp shadows, very, very like straightforward, and there's no kind of, a tree doesn't look like a building, right?
Right.
So some things around there to keep an eye out. Then another thing I'd mention is light probes. So light probes are a very interesting special thing. What they do is you place light probes in your scene, and what they do is they store lighting data that will then affect what your assets in scene are doing. So it uses a special technique called spherical harmonics, which is a special way to compute uh, lighting data and how it interacts with the vertex data. Because when we're rendering meshes, we're thinking about each vertex and how we're going to render from vertex to vertex rather than the entire mesh at the same time. So with spherical harmonics and light probes, what you're doing is you're pre-computing how into a single vector the effects of lighting, and then as the assets are going to change in real time, instead of recomputing everything from the right light, you have that pre-computed vector stored in the light probe, and then depending on the position of light probe, it then recomputes what lighting would look like within your scene. So that allows you to have a little bit more real-time lighting while also keeping your costs low. And then, another thing I would add on top of that is baked lighting will probably be more beautiful than real-time lighting, because there's a lot more you can do if you pre-compute those calculations and just bake them in a lookup table instead of having to compute it real time every frame, because that will take up a lot of your budget. But yeah, I could talk about light baking for hours and then, so I'm going to stop right here.
Well, I want to add a note that first of all, thanks for teaching me something. I had never heard the term spherical harmonics before. But I know you're a huge math guy. So but like that's the beauty of real-time 3D engines, not to toot our own horn, but I've used light probes a lot. Never heard the term spherical harmonics, right? But I know how to use a light probe and I know the benefits. So if you don't want to learn spherical harmonics, you don't have to, but also maybe you should, because it sounds kind of cool. But yeah, so that's a huge thing, right? And again, depending on the needs and the outcomes, you can optimize how you change things. Let's jump to our next tip. The frame debugger. So we've mentioned it already once. I wonder if I have screenshots in here. I do not. Okay. So the frame debugger, you go window, analysis, frame debugger. So it's actually going to show the draw call information, and it's going to let you control the playback of the frame. So you can actually step through every single draw call and see what's being drawn where. And for me, the biggest win of that on the under construction frame is then you can see the order things are being drawn, and you can see where occlusion's not working. As an example, you might have a really cool scene with a big old ogre in it, and there's a hut behind the ogre, and you draw the entire hut, and then you draw the ogre, and the ogre's right in front of the hut, blocking everything but the thatched roof. And you're like, oh, so I'm drawing like all these tries and all this stuff and all these shapes. I'm rendering all this stuff, and then the player's not even seeing it, right? So you can get a really good look into like the order of your draws and start kind of working on how to kind of utilize that.
Yeah, no, that's a great point. I think just to kind of build on top of that, that's why what we prefer a rendering technique called front to back rather than back to front. That way, whatever's in front, you render first, and hopefully, whatever's in the back at that time, your occlusion's kind of coming in and only rendering what's needed from the the object in the back. And that is done through a specific buffer called the depth buffer, which essentially is either an 8-bit or a 16-bit buffer that stores value on what the depth for an object is, and then your shader, essentially your GPU, does a check on the depth values of the object that's rendered in front versus in the back. And then if the depth value per pixel is, it doesn't, that you can set your own rules, right? So even if you've used Unity's shader system, you've probably gone and adjusted the depth stencil in different ways. So it's essentially based on the kind of setting you've set, it decides to whether not render it, cull it, only render few pixels about it. So those things end up mattering a lot. Another thing I will say about frame debugger is, I think so. I keep referring back to games, so I hope people know these games. But I was working on Ruined King for PS5, and there's a few scenes where you kind of get onto like a top higher ground place, and then you look down and it opens up into a vista and it just slows the game down. And we knew it was rendering related because everything else in the game was running fine. And as we'd open the profiler, the profiler is color coded. So light green generally means graphics, right? And graphics doesn't mean GPU. It means it could be whatever data is being translated on the CPU to be sent to the GPU, right? That includes culling and things along those lines, right? So the frame debugger is a great way for you to, like Thomas said, step through. And what I mean by step through is you can see all the draw calls on a single hierarchy. And then if you go to the first draw call, the whole screen is black, and just a little object, either it's a UI or other thing that's being drawn by that single draw call is all you see. And as you move down a draw call, you'll see whatever object that second draw call is drawing pop up on your screen. So you can see what the draw call is in real time, and what it's drawing on your screen. And that'll allow you to see things like overdraw. What's overdraw? Overdraw is what Thomas was talking about. We just give it a name, is drawing things on top of each other, right? So generally, overdraw is something you cannot really avoid, because if you're rendering sprites on a 2D game on a mobile application, you are going to draw a mesh and then a mesh on top of a mesh and then a mesh on top of a mesh, right? But at a certain point, overdraw becomes too heavy, right? So for example, if I have 4 layers of overdraw, maybe that's okay, right? But if I jump up to 8 or 10, maybe that is just, a little too much. So it's not about, hey, I just cannot draw anything, everything has to be a single pixel drawn, or, no pixel can be redrawn more than once. That is probably not achievable in anybody's game dev career. I've never seen something like that, where your entire screen, each pixel on the screen is only drawn once. If you're able to achieve that, give me a holler on LinkedIn, because I would like to know how. But, regardless, I think it's very helpful to see if you're overdrawing, if there are things that could batch together, because it also shows you batching information like we talked about earlier. So you can see the theme here is that we talk about the things that can affect performance, and then we give you the tools to check and kind of identify those things that we talked about and actually take action on that.
Yeah, totally. And with that, we've talked about graphics quite a lot, and you're all like, wow, these guys are nerds. And we are. But I want to jump forward because we got more stuff. Let's talk about optimizing code. Because this is something I know a little bit about. So we'll dive forward on it. So let's talk about object pooling. So just like level of detail, just like reducing triangle count, just like, batching your UI, dynamic batching, static batching, object pooling is a really powerful thing, right? And we brought this up kind of briefly when I never heard stuff said. It was like, I don't know that I destroy that UI. And he kind of mumbled it, right? It's because destroying stuff and creating stuff takes resources, right? And if you're going to reuse it over and over again, instead of constantly destroying it and recreating it, you should just keep it alive and put it somewhere and then go get it when you need it again, right? And so that's like, you create a pool of objects to reuse, bullets, collectibles, items, whatever they might be. And then you just manipulate like their transform or activate, deactivate them, set their transparency to 0. And so then you're reducing the amount of garbage collection you're creating in the engine. Garbage collection is essentially reclaiming memory. And there's a process that has to do that, which uses resources to do so. And then it'll also avoids large amounts of instantiation, creating and allocating memory that way. So you can just already have the thing. The most notable thing for this, of course, is bullets, right? You're shooting a machine gun and the bullets only go this far. You could probably just have 10 bullets that are just cycling and you're good to go, right? So it helps just reduce your resources in your account there.
I think some other things is probably like particle effects, right? So if you have fires, embers, those kinds of things, pretty easy to kind of pull them, keep them in your memory, things like that. I can't stress enough about garbage collection. Garbage collection can cause massive headaches, and I've seen expert developers struggle with things like garbage collection. So anything you can do to reduce garbage collection, do it right now.
That's actually a thing for Unity too, right? Like we as a company, as an engine, are constantly working on reducing the impact of garbage collection inside the engine, right? Like it's a thing. And you'll know what it is because when you look at it in the profiler, you'll just see like on one part of a frame, you're just going to see this big spike and you'll be like, oh, found it. Found the garbage collection.
It'll be called gc.collect.
Yep. That'll be the one. So this may not be as true today as it was when I put this together, but like cache everything, put everything in a box, hoard it, keep it all. don't throw it away. And what I mean by that is you don't need to be looking up references to stuff all the time. Now, there are some things that you can get away with now, like camera.main is actually a cached value at this point. So you can just use camera.main and you're fine. That used to not be the case. But, if using gameobject.find is generally process intensive, right? Depending on the size of your scene. Because the more stuff is in your scene, when you say, yo, find me find me the game manager, and the game manager's there, but there's 4,000 other objects in the scene. That means it's going to search everything in the scene until it finds that, right? Or find me the player. Cool. I'm going to search the entire scene so I find the one thing tagged as player, right? It's expensive. So if you have a script that needs it, get in a reference to it off the jump, cache it, and then you can just re-reach to it, right? If your game manager needs to know where the player is, just get a reference to the player right away and then just reference it whenever you want. And I'd love to hear your opinion on this, but like I think about it like as a coder, I'm like, oh, it's more fancy if I get it through code. But you can just left click and drag it into the field and then it's there, right? And you're set. So
Yeah, no, absolutely. And honestly, I think even if you want to get it through code, you can do getters and setters, right?
yep.
So depending on how you've specified your accesses for your class variables and methods, you can set either a getter setter or you do a function call, method call, which then gives you the value back. But no matter what your preference is, there is a way to cache a value.
Yep.
And if you can cache a value, you gotta cache a value, right? Because I like the amount of the game object.find is just atrocious. You really don't want to do that.
It's rough, yeah.
Yeah, camera.main a lot better now, but still, if your camera isn't, like if you're just using the same camera over and over again, why continue doing camera.main over and over again, right? The code is going to get bloated. You're going to still have some extra computation going on there because then you have to go through search through a namespace instead of just pointing to a value that's already stored somewhere, right? So there's still kind of like if you were to dig deeper into there's different kinds of profilers, and again I'm probably going on a rant, but there's instrumentation versus sampling profilers, and the difference between them is how they measure the performance of whatever you're trying to measure. And I won't go into further detail, but if you were to look into an instrumentation profiler, you'd see further information on what's happening in your OS and not just in Unity. But yeah.
Yep. No, totally. Couldn't agree more. And like, again, this comes into it is if you know you're going to use something a bunch, you're going to save yourself a ton of optimization work on the back end if you just cache it. Like legitimately, when I write code now, I'm usually just like cache it. 3 seconds now saves you a couple hours later.
Cache me aside.
Cache me outside. All right, so remove debugs. So when I test stuff, I'm a big fan of debugging, right? I'm like, oh, this isn't working. I don't know why. Debug.log, did this thing work? And then I hit play and then I see if it prints right in the console. It's a pretty common debugging method. Did you know that those are kind of expensive? It's kind of cost power, right? So a pro tip I like to offer, and I'd actually like to hear it. So I was like, I think this is a good tip, but it could be just expensive anyway. So I just do a little if statement and I make a little Boolean called debug. And then I do if debug the thing or do whatever I want for the debug. And then I can just turn that off and off and on in the inspector. So then I can just go, instead of having to go through and comment out all my debugs or delete them all, I can just go off. And then it's just checking an if statement. It's not using the debug stuff and we out of there, right? It's again, just looking at the thing and saying, do I need to debug? Nope, I'm out. Which so you are still technically adding some performance because you're looking at the debug statement, but that's a lot better than actually printing the debug to a console that your end user is not going to see.
Yep, I'll actually do you one better. So there's different macros you can use. For example, you can use if Unity editor, or you can do platform specific macros. So for example, you're like, I want the debug log for my test build on my Android device, but I don't want it on PC. So you could do like if Android, or you can find what the actual macro
I think it
word
actually
is.
is if Android. I think it is if Android, and I think Android's all caps. Yeah.
Yep. So use those macros. They will automatically strip code out when that macro condition is not satisfied. So for example, if it's not an editor, it'll strip out that piece of code entirely from your code. And if that causes any problems, hopefully you'll see that in the console as you run and test your application or game on the target device.
I hadn't even, it's funny. I use those for other stuff. I had never even considered using them for debug. Dang.
Trust me,
Dang.
optimization is a thing I learn about every day. Like even now, like sure I know a lot, but I learn something new every day about optimization. It's a never-ending journey of learning.
Use coroutines over update. If you don't need to check it every frame, don't do it. Coroutines work very similarly, and you can also tell them to stop. So it's pretty helpful. Yeah, you can also use delegates or events. I'm a big fan of event handling, right? There's like updating UI is a common trap for beginner programmers where you'll be updating the UI. And so every frame, you're just checking that value to make sure the UI is up to date. When instead, you could just have an event called UI event update thing, and then you put the value in it. And when the thing happens, that event fires and boop, it updates it and you're good to go, right? Saves you a lot of processing, a lot of thinking.
100%. And just to add to that, I think you could also try to use Burst compiler and native programming, but I think that may be a little complicated for this audience. But I would encourage you if you really get deep into the optimization realm, look into Burst compiler and how to do native programming versus C# programming within Unity,
Yep.
and then that can only be done for very specific instances. But yeah, I encourage you to do that.
Okay, we already talked about this a bit, but I want to add this note. Use the profiler. Like use our profiling tools. They're literally there for this, right? These tools have been built to be used. It's not going to catch everything. It's not a catch-all, right? But it's gonna get it's your magnifying glass into the world of what's going on in there, right? It's how you see inside the code and see what's going on. It won't tell you exactly, but it'll get you close. Then you can apply optimizations and you can reprofile to see if the work you did actually mattered, which I find exciting. And it's iterative. I want to refresh this. The optimization is iterative. You do the thing, you make the fix, and then you go back to that process inspecting again. If you find out that you're GPU bound, you're going to do a lot of frame debugging, and then you're going to go fix all that frame debugging and then go see if it had an impact. And if you're CPU bound, same thing, but with the profiler, you're going to be going through that over and over to see that you're really locking down those issues.
Yep. And another thing I'd add is you can actually add custom profile markers. So essentially, if you have a specific function within a class that you think takes longer than other functions in a class, but within Profiler, it shows up as a whole class, you can then add a profile marker for that function alone and keep track of that each and every frame, depending on what function it's fulfilling, what the code is doing, to check exactly how much time is spent in that specific piece of code. And that is a godsend, honestly, when you're profiling games, and especially game logic.
Yeah, that's actually another good pro tip I didn't know about. All right, so there's two loops. So you've got a player loop, and then you've got like editor loop, right? So worth noting that the low-level player loop and I might be describing this incorrectly, describe if I'm wrong with Utsav, but the low-level player loop you're going to see in the profiler, that's not your code. That's the engine, right? And that separates gameplay code from the editor code. So excuse me, the player loop is what you're contributing to. The other stuff is the editor code. Your code is what contributes to the performance. So your code contributes to the player loop, not the editor loop. So just
Yep,
beware of that.
Yep, that's correct. And honestly, I'm actually putting a Medium article from one of my old teams. He was my coworker in my old team, which was the one that did profiling, that actually walks through the actual events that happen. So for example, what's fixed update, pre-update, pre-late update, post-late update. So for example, physics operations happen in fixed update, whereas particles generally happen in post-late update. And then initialization and early update is mostly just setting things up, right? So it's very helpful to understand where these operations occur for you to really know what you need to kind of focus on and really change. Okay, optimizing memory. So I think we've talked about what CPU, GPU, graphics. Memory is a very different kind of beast, and it really comes down to whether you're crashing or not. It's there's a very easy way to find out if memory is your bottleneck. You will crash if memory is your bottleneck. Um, so how do you actually get through memory? So I think I'm going to probably go back to tools, and then there's two primary ways to look at memory usage. It's memory module in the profiler or a memory profiler itself. I'll let Thomas add anything if he wants to add anything.
No, actually, I'm gonna ask you for the big solid. I think that really, that's the memory module right there, and then the profiler. We pop this thing open for Q&A and let you, if there's anyone that has any like questions, if you can handle that, and I will sneak away and tell you all that it's been wonderful. Make sure check in the Discord to enter the drawing. There is a survey that the link is going to get posted to at the end. If you don't fill out the survey, you can't enter the drawing to win. So, yeah, that's cool with you. Utsav. I'll sneak away and I'll let you handle Q&A.
Yeah, I got you, brother.
All right, y'all. It's been wonderful. Utsav's got you for Q&A, and we'll talk again soon.